Hello, ladies and gentlemen. I'm going to give you one more example of energy pie charts that you can refer to as you're trying to do your example problems today. So the situation we're going to look at that I'm going to walk you through is a penguin who is on a sled who is going to be sledding down a snowy hill. So remember, the first thing we want to do is try to identify everything that is in the system. And so, for example, in this situation, we're going to include the penguin and the sled that it's on. We're going to include the hill or the surface that it's sledding on, as well as the earth, since this is happening on or near the earth. So you'll notice here that the objects that make up my system have popped up here on the screen. For some of the problems that you will do today, you will be asked to list out all the objects in the system. Try to list everything that is a part of what's going on, just like when we used to do our system schemata for forces, because it makes it easier to identify all the types of energy that are happening. So you'll also notice down here I have 4 kind of guiding questions that you can ask yourself in all of the different problems that you're going to do today. So for each snapshot, I'm going to ask myself these 4 questions so I know what energies I need to include in my pie chart. So let's look at snapshot A. The penguin's at the top of the hill, and notice that the penguin and sled is not moving yet, so it's at rest on top of the hill. So the first question here is the object moving? The answer is no, so I know I'm not going to include any kinetic energy in my pie chart. The second question, does the object have potential to fall towards the earth? My answer is yes in snapshot A. This penguin and sled could start sliding down the hill in that situation. So it has the potential to get closer towards the center of the earth. So I know I'm going to include some gravitational potential energy. Third question, are 2 objects touching? If yes, we should include thermal. This situation, yes, the penguin and the sled are touching the ground or the hill, but I'm actually going to ignore thermal energy because when we have a slippery surface like snow, we know that there is such extremely small friction that would result in an extremely small amount of thermal energy. If you want to add a little bit of thermal energy into that first pie chart, feel free. So then the last question is a rubber band, spring, elastic, or bungee cord, etc. involved in the situation. And no, none of those things, no elastic materials are involved, so we're not going to include any elastic potential energy. So in this situation, we said that only potential energy was going to be involved, so I'm going to give 100% of the pie to that potential gravitational energy. Again, if you wanted to add a little bit of thermal energy in this situation, that would be okay. It would not be incorrect. So now looking at snapshot B, the penguin and the sled are now halfway down the hill. The first question, is the object moving? The answer is yes, so we know it has to have some kinetic energy. The second question, does it have the potential to fall towards Earth? Yes, it has the potential to fall down the rest of the hill, so I know I'm going to have to include gravitational potential energy. Again, there are 2 objects touching, the snowy hill and the sled, but we're going to ignore thermal energy again just because it's such small in the situation. And so when we go ahead and add our pie chart in, we now know we need some kinetic energy because it's moving, but there is still potential energy. Since the penguin and the sled is about halfway down the hill, I gave half the pie dedicated to that potential energy. Snapshot C, the penguin is now going the fastest speed it's going to be going because it's now at the lowest point of the hill. So yes, it's moving. We know it's going to have more kinetic energy than in B because it's moving at a faster speed. Second question, does it have the potential to fall closer towards Earth? The answer is no, because it's now starting on a flat surface, no longer going down that hill. And still no elastic materials are involved, so no elastic potential energy is going to be included. So we're going to give the entire pie over to kinetic energy in this situation because of the motion of that penguin. So now snapshot D. The penguin has now stopped, so we know there is no kinetic energy. It's at the lowest point that it can get towards the center of the earth because it's now on flat ground, so there is no gravitational potential anymore. So in this situation, we are going to now say that all of the potential and kinetic energy that the penguin and the sled did have earlier on has now been changed over to thermal energy. That's what actually ended up getting it to stop is that little bit of friction. But that's why you can go such a far distance on a sled, because of the little friction that there is. So it takes a long time in order to get a sled to stop. But again, that would all go to thermal energy. So it changed from potential and kinetic over to E-therm. I mentioned this with some classes yesterday, but remember that mechanical energy is just total energy. So at each one of these snapshots, the pi itself is the total mechanical energy. Mechanical energy is potential and kinetic added together. And so at each point, the entire pi is the mechanical energy in that situation. Just a quick reminder, don't forget that you have the examples we talked about yesterday that you can refer to as well as you're working through some of the problems today. Make sure you're working together and collaborating and asking good questions to get through the examples on pages 3 through 5 of your learning guide. And then keep in mind that those pages are going to be due on Monday along with the Energy Skate Park sheet. Have a really good weekend, and I will see you on Monday.